Okay, so today we're going to be talking about the Jones oxidation. This is a second semester organic chemistry reaction, and it's very quick, very easy, very straightforward. So we're just going to get into it as quick as possible. So Jones oxidizing agent is a strong oxidizing agent, and it was discovered by Sir Ewart Ray Herbert Jones, and we have him here on the right. So he helped define chromium-based oxidizing systems, and the Jones reagent is a chromium-based oxidizing system. So it uses chromium trioxide, which is dissolved in concentrated sulfuric acid. So the gist of this reagent is that it transforms primary alcohols to carboxylic acids and secondary alcohols to ketones. So it's very, very straightforward. Okay, so let's get to the mechanism of it all. So let's say we have a secondary alcohol. So we have two R groups here, and then we have our secondary alcohol. Now, let's say we take this, and we take the secondary alcohol, and we have some of that chromium trioxide. What is going to happen with it? So, with the chromium trioxide, our first step is that we are going to take one of the lone pairs off of the oxygen right here, and that lone pair is going to attack the chromium in the middle. Once it attacks the chromium, that will cause this bond to break and for those electrons to move up. Once those electrons move, we're going to have this very, very weird looking thing here. We have the oxygen, and we have the hydrogen that's flanked off the oxygen. Then we're going to have our chromium system. So we're going to have, this is the same, and this is the same. However, we know that because these electrons are moved up, and we have an oxygen here. Now, there's something special about this oxygen. It must have a negative charge, and this oxygen is going to have a positive charge. Okay, so our next step is we're going to move some things around because this is pretty unstable. So this negative charge from the oxygen is going to attack the hydrogen here, and this bond from the hydrogen is going to move up onto that oxygen. So from there, we're going to have a little bit of a different looking structure. So like before, we have our two R groups. We have an oxygen, we have our chromium, and we have our two oxygen groups here. Now, we also have an alcohol that forms because if we see again, the charge here will attack. Now, there's also something else that I want to document in here, which is important for the next step. We have a hydrogen that's flanked right here. And if it helps, I can draw it in on these two other ones. You see hydrogen and hydrogen. Now, this hydrogen is important for the last step because we're gonna have the addition of maybe some water. If we add water here, water's lone pairs are going to be attacking our hydrogen here. Then the bond from the hydrogen is going to help make a double bond there. And then all of this is going to be a leaving group. So what we are left with is a ketone. Excuse me, bless me. Okay, so now this is the mechanism of what we're looking for. Let's go ahead and do some predictive product questions. Okay, so as I said before, we can see this on our other slides, that it's used to transform primary alcohols to carboxylic acids and secondary alcohols to ketones. So let's go ahead and use that in some predictive products. So let's say we have this as our first, and we'll go ahead and do another for our second. Okay, this is our second. And for our third, we will do this, and let's do this. Okay, so what is going to happen when we use Jones reagent for this? So if we use Jones reagent, we're going to have the formation of a carboxylic acid because it took a primary alcohol to a carboxylic acid. Now, if we use Jones here, we are going to form a ketone. Just like in the mechanism we just did, a secondary alcohol will always become a ketone. And then finally, if we use Jones oxidation here, we're going to have two different products. We're going to form on the left side, on the right side, we're going to form a carboxylic acid. And on the left side, we are going to form a ketone. All right, those are 3 examples. Let's do a couple more. Okay, so let's say we have something a little more complicated, and we'll make this one a lot bigger. Okay, so we have a ring, and on the ring we have this group, this propyl group that goes off of it. Let's have an oxygen here, and let's have an oxygen, or an alcohol, sorry, in both these places. And you already understand the secondary one. We don't have to do that. Okay, and we're going to use Jones here. What do we get? Okay, so we know that when we have a primary alcohol, we are going to get a carboxylic acid. So we're going to go ahead and just start there. Okay, so you get the carboxylic acid. Now, something that we haven't talked about is the difference between what happens when there's a tertiary alcohol. So when there's primary, we get a carboxylic acid, and that's primary. When it's secondary, we get a ketone, and we've seen that. And this is tertiary. So when it's tertiary, what do we get? That's a trick. When it is tertiary, we don't get anything. There's no reaction there, so we're just going to have our alcohol stay there. That is what we get for this product. And let's finally do one that's a bit of a challenge question, just for our last one. So we'll have this. We'll have the alcohol here. We'll have another alcohol here. And then we'll have this. We'll have this one here and this here. Okay, so if we had this, what would we get? So we would get a ring. First off, we would get a secondary alcohol. We would get another secondary alcohol. We would get a carboxylic acid here. And here we would get no change. So this is, pretty unlikely, but it's good for practice, and we have all of these so we can practice what we do. Good luck learning this. I think it's fairly simple, and I wish you the best. Thank you for watching.